Let us take up question number 40 today, physics problem 40. Topic for the discussion is friction. You can take this as an introductory example on friction. Statement of the question is, you can see, on the board you can see the statement. Suppose a block is placed on the floor, as a horizontal surface. What is the minimum force required to move it? Now suppose you apply the force horizontally like this, as you see in the first diagram. The minimum force required will be, if applied horizontally, minimum force required to move this. Required is F equal to mu into R is the normal reaction, which is the weight, mu into mg. Where what is given here is not mu, it is the angle of friction. Meaning of the angle of friction, as far as this problem is concerned, if you understand the meaning as mu equal to tan lambda is enough. Actual description of lambda I'm not doing now, but mu is equal to tan lambda, which implies F is equal to mg tan lambda. So, if that force is applied horizontally, you can move it. But the question, that is not the answer to this question, because if you apply the force at some other angle, you can still reduce this force. Force to move this, just to moving this on the surface is the requirement. So that can be done even with a smaller force. What is that smallest force, and what is the, for which it has to be applied at a certain angle, and what is that angle? That is what we have to find out. So we go by the second diagram. In this diagram which I have drawn, let the force be at angle theta to the horizontal, and we write the vertical equilibrium condition. For vertical equilibrium, the normal reaction R plus F sin theta must be equal to mg, because upward force equal to downward force, mg, which gives us the value for R in terms of the applied angle and then the force. We are going to get a general expression for F. Then we minimize it. So R is equal to mg minus F sin theta. Limiting friction is this, F limit, mu into R. Here F limit, earlier it was just mu mg, now mu into R will be different, R is this. So, for when the block just moves, this is for the vertical equilibrium, what I have written is for the vertical equilibrium. When the block just moves, horizontal equation is F cos theta must be equal to mu R. F cos theta equals mu R, where mu is tan lambda, R is mg minus F sin theta. So this we further expand. F cos theta, this implies F cos theta is equal to mg tan lambda mg tan lambda I will write as sin lambda by cos lambda minus f sin theta. Tan lambda I will write as sin lambda by cos lambda. Sin lambda by cos lambda. So from this, if we further simplify, we get this becomes f cos theta cos lambda equal to mg sin lambda minus f sin theta sin lambda. So we get that solving, we solve it for f general formula cos theta cos lambda plus sin theta sin lambda is equal to mg sin lambda. Now after I clear further, I will further discuss this after clearing the part of the board. Okay. Let us continue the steps. Our last step we can rewrite as the last step as f cos. That expression, trigonometric expression is equal to cos theta minus lambda. On the left side, it is equal to mg sin lambda, which implies f is equal to, general formula for f is mg sin lambda by cos theta minus lambda. This has to be maximized. We know this will be, okay, this we have to minimize actually, this we have to minimize. Cosine has a maximum value of 1, which corresponds to cos 0. F minimum corresponds to cos theta minus lambda is equal to 1 or theta equal to lambda. So this is, all thing is 1 means f minimum implies f minimum equal to mg sin lambda. This is the minimum force that we require to be applied at angle theta equal to lambda. To be applied at theta equal to lambda. That is the angle of friction. At the angle of friction, if you apply, this force required will be minimum. So this has to be equal to lambda. This question, so now you can also see that earlier for horizontal application we got f equal to mg tan lambda. For any given angle greater than 0, sin lambda is, for theta greater than 0, sin lambda is less than tan lambda. So earlier we got tan lambda, now we are getting sin lambda. So this is a smaller force than this, and that must be applied at this angle equal to angle of friction lambda. This question was long time ago, this was asked in the IIT. They are, instead of giving angle of friction, they have given the coefficient of friction itself directly as mu. So in terms of mu also you can apply this, you can express this answer in terms of mu also. Because sin lambda being tan lambda being mu, so this is mu means this is 1 plus mu square. So in terms of mu, this answer you can give us in terms of mu, f minimum is equal to mu by 1 plus mu by, that is sin lambda being mu by 1 plus mu square root times mg. You can give f minimum like this also in terms of mu. But but this question states angle of friction lambda, so in terms of lambda this is the answer. I think you can follow this explanation. Thank you.